Dear students, so we are starting with our next manufacturing process, that is machining or metal cutting processes. Now in machining or metal cutting processes, the different machine tools we are used to this machining or metal cutting processes. So we will see in this video, we will see the lathe, that is the first machine tool that is used is the lathe machine. So we'll start with this first machine tool, that is the lathe machine. So we have different metal removal, or it is also called as a machining process, where we remove the material from the workpiece and we will have a finished product. So metal removal or machine process, it is an manufacturing process in which the product of desired size and shape is got. We get the product of desired size or shape, or a component of desired size or shape, by removing the excess material, or by removing the material from the workpiece by means of some machine tool. Okay, so from that machine tool, by using that machine tool, we remove the excess material from the workpiece, and we have a component or a product which having a required, or you can say desired size and shape. So that process is called as a metal removal process, or it is also called as machining process. Why it is called as a machining process? Because we use some machine tools to remove that metal. So it is also called as machining process. So a machine tool. Now, what is meant by a machine tool? So machine tool, it is a device which securely holds the workpiece. Okay. So now workpiece, it is nothing but a product which is a raw material. We convert this raw material into finished product or finished component. So a machine tool which a device which secure this workpiece, and the cutting tool, it is used to performing some or various machining processes or various machining operations. So we have machine tool, it is a device which hold that workpiece, and the another one is cutting tool. So cutting tool is also held by a machine tool. So by using this cutting tool, we perform various machining processes, or we can say metal removing processes. So what are the machine tools? If you see, the machining is the process of forcing the cutting tool. Okay, we have one or more cutting edges. Now in lathe machine, we use the single point cutting edge, or you can say there is a single cutting edge is there. While in case of milling machine, we have multiple cutting edges. While in case of drilling machine, we have also multiple cutting edges. So machining is the process of forcing the cutting tools with one or more cutting edges through which we can remove the excess material from the workpiece. So what are the machine tools that are commonly used while in this machining process or metal removal process? So first machine tool, it is what is meant by a machine tool, then we will see the types of machine tools. So a machine tool, it is a power driven machine. Okay, so machine tool, it is a power driven machine which is used to making a component or a product of desired shape and size, accuracy and surface finish by using the material from the workpiece. So by removing the material from the workpiece, we can have a component of a desired size, shape, accuracy and the surface finish. So the machine tools are used for carrying out these metal cutting processes, or it may be having surface finishing processes. So each machine can carry out a single operation or single machining process or more than one process. So that is called as a machine tools. there are different types of machine, or we can say machine tools. So first one is lathe machine, where we have a cutting operation will be there. Different material removal operation will be there. That is the mainly metal cutting operations. Similarly, in drilling machine, again, the both metal cutting as well as some surface finishing operation that can be done on this drilling machine. Similarly, we have shaping machine, milling machine, and the planing machines. Okay. So other machines are there, that is grinding machine and all that. So, but these are the main machines that is used in any production process or any workshop for removing of the metal, or we can say machining processes. So in this video, we are going to see the first machine tool, that is the lathe machine tool, and the operation which are performed on lathe machine that we will see in the another video. But in this video, we are going to see the first machine tool, that is the lathe machine. So if you see the first machine tool, that is the lathe machine. So a lathe machine, it is one of the oldest and most important machine tool. Okay. So lathe machine, it is the one of the oldest and the most important machine tool for any machining operation or any metal removal, or we can say machining operation. Now, if you see, the lathe machine has become a more general purpose machine tool because it is most widely used in a production process, or we can say in the manufacturing works. So the lathe machines, it removes the excess of the materials from the workpiece by rotating it against the cutting room. So if you see the working principle behind this lathe machine, or we can say machine tool, it is, so the workpiece, it is rotating. Okay, so we have a workpiece which is placed on this chuck point, where by means of a power driven mechanism, the chuck will be rotating, and because the workpiece is placed or hold inside this chuck, so this workpiece is also rotating. So in every machine tool, or I can say every operation which is done on a machine tool, the main important thing that the workpiece is always rotating. Okay. And there is some cutting tool is there. So this is the tool paste where the cutting tool is feed against, or we can say the cutting tool is feed against the rotating workpiece, and because of that, the material gets removed. And there is a support is there. So generally for supporting this workpiece, we have a tailstock arrangement is there. So this is one of the machine, that is the lathe machine, which is shown in this image. So the tools, or you can say a cutting tool, it can be fed deep, through which we can remove the excess material. And the job is held between the rigid supports. So workpiece, or it is also called as a job, it is held between these rigid support, that is called as a chuck. Okay, so we'll see the different components of this lathe machine and types of lathe machine in this subsequent video part. But this is the lathe machine. Okay, so it is the most important machine tool for any production process or for any workshop. We have this lathe machine. Okay, so we'll see the different types of lathe machines that is used in workshop, or you can say in production process or in machining process. So a lathe, they are classified based on various types. It may be called as speed lathe. Then we have engine lathe, bench lathe, tool room lathe, turret and capstan lathe. So we'll see these all types of lathe one by one. So we have a first type of lathe, it is called as a speed lathe. Okay. So here is the image of the speed lathe, which is shown in this figure or in this image. So speed lathe, it is the simplest form of the lathe. Speed lathe, it is the simplest form of the lathe. It consists of all main components of the lathe, as like in case of, if you see, we have headstock, chuck, tool post, bed, then tailstock, carriage assembly is there, feed rod is there, lead screw is there, bed is there. So all these components are same as in case of the speed lathe. Second one is the headstock spindle. So we have this headstock spindle. So this is called as a headstock, and this rotating part, it is called as a spindle. So headstock spindle, it can rotate with very high speed. Usually, it is driven by variable speed motor. Usually, it is driven by a variable speed motor, which is built inside this headstock. So if you see, this part is called as a headstock. So inside this headstock, we have a variable speed motor. Now the workpiece is held between two centers. That this is one center that is called as live center, and this tailstock center, it is called as dead center. So the workpiece is held between the centers or attached to some other work holding devices, and the tools are hand operated. So in this field lathe, this tool is fed by using a manual or by using a hand operator. So it is called as a speed lathe. Generally, this speed lathe, it is used for woodworking operations. So the operations which is done on the wood, that is done by using this speed lathe. Similarly, we have metal spinning operation, metal polishing operations that are done on this speed lathe. Okay. So these are the some operations that can be done on speed lathe. Now, we have another type of lathe that is called as a center lathe or engine lathe. Now, this is the most commonly used lathe, that is called as a center lathe, or it is also called as an engine lathe. So it is the most commonly used lathe, and it is normally used for in all types of machine shop, or it is used in all types of workshop. That is the center lathe or engine lathe. Now, it is a earlier in its earlier version of this center lathe or engine lathe. The steam engine is used to supply the power, so it is called as a engine lathe. So, in additional feature of varying speed in lathe spindle is compared to in this speed lathe. So, if you see, what is the main difference between this speed length and can say this center length or engine length? It is there is a varying speed is there. Okay, so we have different speed for different operations. So that varying speed is very much important, and the main additional feature than this speed lathe is we can vary the speed. For every operation, we need a different speed. For different diameter, we need a different speed. Again, the wide range of attachment that can be fitted in this center lathe, or we can say engine lathe. So almost all operations that can be done in center lathe or engine lathe. Now, next type of lathe, it is called as a bench lathe. Now, bench lathe, it is a smallest length, or we can say small length, which can be mounted on a single bench or a bench. So it is called as a bench length. So if you see, this is the bench length. So it is a mounted, all this length equipment, it is a mounted on a bench or a base. And this is the smallest version of lathe machine, that is called as a bench length. So this bench length has same features as that of the speed lathe, or we can say center lathe or engine lathe. But different is that it has size and mounting is the main difference between all these lengths. So size is very small as compared to both speed length as well as the engine length. And also the mountings, it is mounted on a bench. There is a not bed is there, so there is a bench is there. So that is called as a bench length. Hence, this bench length it finds its wider applications or wide applications in small or light works. So where there is a small components are there or small product is to be manufactured or operations is to be done on small product. So in this we use this bench lathe. Now next type of lathe it is called as a tool room lathe. So as name suggests, it is mainly used for accurate tool room works. So it is the most modern engine lathe which is employed for making the small tools, that is small cutting tools, then different test gauges, dies, and other precision parts. So where in this tool room lathe, the small parts they are manufactured by using this tool room lathe. Okay, so this is an image for a tool room lathe. Okay, so we have a headstock with has a very small component that can be joined, that can be hold, and we can have a different tools, test gauges, dials, and other precision parts that can be manufactured or machined in case of this tool room lathe. The next type of lathe, it is called as a special purpose lathe. Now, this special purpose length, it is used for some special operation or for a special purpose. So, in addition to above types, some lathe, it is called as a specially designed and manufactured. So, that is known as the special purpose lathe. And it is used for doing some specific sets of operations for making a particular product. So, such lathe is called as special purpose lathe. So, for example, one of the special purpose lathe, it is available for making crankshaft, or you can say car wheels. So, it is only used for making this crankshaft and car wheels. So, that is called as a special purpose lathe. So, here the example is of a special purpose lathe. So, generally it is used in where the job is long, the distance is long, so we can move this jaw, or you can say this head as well as tailstock along this length, and so that we done the operations, various operations on this job. So this is called as a special purpose lathe. So we have only special purpose, or we can say specific sets of operation that can be performed on that only that machine. Okay, so that is called as a special purpose. And the last lathe, it is called as a turret and the capstan lathe. Now, this turret or capstan lathe are the production lathe having a provision for holding the different or several types of tools, and that several types of tubes or tools that performs the various operations or wider range of the operations within the minimum time. So for that, we use this turret or capstan type of a lathe. Now, the cost of this turret or capstan type of lathe, it is very high because the several tools that can be held in this lathe, and because of that, the cost is gets increased. So this is an image for a turret or the capstan lathe. So we have a different holding arrangement is there that will holds the different types of tools and the different operations that can be performed on this turret or capstan lathe. So these are the main types of lathe we have seen. That is starting from speed lathe or engine lathe. Then we have center lathe or engine lathe. Then we have the special purpose lathe, turret and capstan lathe, and bench lathe. Okay, so these are the some tool room lathe. So these are the some types that are mainly used in industry or any production process. That is from the oldest one to modern ones. Okay. Now, the main we will see what are the parts inside the center lathe. So if you see, this is the layout of a lathe. It consists of various parts. So first part, it is called as a headstock. So this part, it is called as a headstock, which consists of this assembly of all these parts and this parts also. So it is called as a headstock. Then this part, it is called as a tailstock. Okay. So this is the headstock. This is the tailstock. So headstock, if you see headstock, the workpiece is held in this headstock by using a chuck. Okay, so here a chuck. There are some 3-jaw chuck will be there, 2-jaw chuck will be there, 4-jaw chuck will be there. Okay, so by using chuck, we can hold the workpiece inside this headstock part. And this headstock part is a live part, or it is also called as a live center, because the power is given to this headstock by using the power mechanism, by using electric motor or any other device. This tailstock is another part that supports the workpiece. So it is only used for supporting. Next, we have a leg or bed. So this part, it is called as a leg or bed. So this is a part which has a leg or bed. Now next one is the tray. So this is the tray part. Okay, so this part is a tray. Now we have a carriage. So this assembly is called as a carriage assembly. So that will move along the length. So that is called as a carriage. Next we have feed shaft. So this shaft, it is called as a feed shaft. So the carriage will move along this feed shaft, and the cutting tool is fed against the workpiece, and we cut the metal from this workpiece. So that is called as a feed shaft. Now another part, it is called as a lead screw. So this is the lead screw part. So it has square thread, or sometimes it has acme threads. Okay, so this is called as a lead screw. Next, we have a half nut lever is there. So this is the lever that is used in carriage assembly. So that is called as half nut lever. Now ninth one, it is called as cross slide. Now this cross slide, we can move in X direction, in Y direction, or in J direction at any angle. So that is called as cross slide. Next, we have gearbox. So some of the machines, we have a gearbox, and in some of the machine, we have the oldest machine, we have belt and pulley arrangement is there. But in modern machine, we have the gearbox arrangement. So that gearbox is there inside this headstock. Next, we have a driving plate. Then live center. So this center where the chuck is fixed, so that center is called as live center. This center, that is tailstock center, it is called as dead center. Then this part is called as a tool post, where it is used to hold the machine tool, or we can say tool. That is called as a tool post. And the last part, it is called as a compound rest. So this rectangular part, it is called as a compound rest. So we'll see these different parts of this lathe machine one by one. So what are the construction of these different parts, and why we use these different parts, or what are the function of these parts? Okay. So we'll see same that is shown in this image also. So we have the headstock. This is the spindle, that is rotating part. This is the chuck where we can hold the workpiece. Then this is called as the cross slide. Then this is your tool post where tool is fitted. Then this is a hand traveling wheel. So we can we can travel this wheel so that it will move along this length. Okay. That is in forward direction or in reverse direction. This assembly, it is called as a carriage, where it carries this all, we can say tool post, cross slides and all. So it is called as a carriage. Next, this part is called as a bed. Okay. So bed of this, which supports this load screw, feed rod and carriage assembly. So that is called as bed. These are called as the leg of the lathe machine. Next, these are the speed control or feed control levers. So by which we can control or vary the speed. Okay. Next, this part is a tailstock. So by using this hand wheel, we can change its length of the dead end. Okay. So that is the hand wheel. Next, we have this lead screw. So if you see this sharp type structure, it is called as a lead screw. So it has square thread and another rod. This rod is called as a feed rod. So that is inside this carriage assembly, that rod is feed rod. Okay, so these parts are there in case of any lathe machine or center lathe mainly. So we'll see the first part, it is called as a bed. So all this part, it is called as a bed. Okay. So what is meant by the bed? The bed is the basic structure of any lathe, and almost 70 to 90% of total weight of the lathe, it is because of this only bed. Okay. So almost bed constitutes 70 to 90% of total weight of the bed. Now, all other parts, so other than bed, all other parts, they are fitted on this bed. So two sets of parallel longitudinal guideways, they are also are in content in the bed upper surface. So if you see, so this is the bed upper surface part and this is the lower surface part of the bed. Now these guideways are precision machine to ensure accurate alignment of other parts. So these guideways has the accurate or precision machine is there, machining will be done so that it have a proper alignment between these feed rod, then we have lead screw, carriage assembly, all this. Then this bed, it is made up of a very strong enough, it is made very strong enough to resist the deflections and vibrations because of different cutting forces is there, and because of different cutting forces there is a deflection or vibration of this lathe machine will be. So to avoid that vibration, it makes very strong. So because of that, it constitute almost 70% to 90% of total weight. So generally the bed is made up of a cast iron mainly, or you can say the alloy material, it gets added into this cast iron. So that is also called as nickel cast iron alloy. Okay. And it is mainly produced by using casting process. Now the second part, it is called as a headstock. So if you see this part, it is called as a headstock. So in headstock, if you see, the headstock is mounted on the left side of the bed. Okay. So in left side we have headstock, in right side we have tailstock. So headstock provides the power required for rotating the work or workpiece. So this provide a power. So by means of electric motor or gearbox, the power is supplied to this spindle and headstock or this chuck, and the workpiece is hold here. And by powering this, we have a movement of workpiece and the tool movement as well. Next one is the headstock receives the drive from electric motor, and in sometimes we use a cone pulley, or we can say belt and pulley arrangement, or sometimes we use a gears, or we can say gearbox for getting various spindle speeds, because we require a different speed for different operations, or for different diameter also we require different speeds. So for that we use the gearbox to increase or decrease the speed, or sometimes we use pulley and belt arrangement. Now there are some speed change lever. So for example, here is the lever is there. So from this lever we can change the speed. So the speed change lever on the headstock, it is provided for varying the speed. The headstock also contains the work holding device. So this device, that chuck, it is called as work holding device. That is workpiece is hold inside this device, that is called as work holding device. So such as chuck, it is a work holding device. Sometimes we use the face plate. Sometimes we use dock plate, but mostly we use the chuck for holding the workpiece or a raw material. So that is called as a work holding device. And this headstock center, headstock is mounted on a live center. Because why it is called as a live center? Because power is supplied to this headstock. So because of that, it is called as a live center. Now we have another part that is called as a tailstock. So if you see a tailstock, it is generally mounted on the right end. As headstock is mounted on left end of the bed, the tailstock is mounted on the right end of the bed. And as headstock is called as live center because power is supplied to this live center, but tailstock is called as dead center because we does not supply any power to that dead center or tailstock. So by manually we can have the movement of that tailstock. So it is called as a dead center. So if you see, this is the tailstock part, or you can say tailstock assembly is there. So here hand wheel is there. So by rotating hand wheel, this dead center, it can be moved along this length. So similarly, again, we can move this whole assembly of tailstock along this guide wedge. So it is called as a guide wedge. So by which we can move this whole tailstock assembly along this guide wedge. So a tailstock can be moved along the length bed to accommodate workpiece of different size. Okay. So we can move this tailstock assembly along these guide ways. So these are the guide wheels or guide ways are there. And we can move this tailstock assembly so that different length of the product, or you can say component, it can be accumulated. Generally, the tailstock is mainly used for two purposes. First one is to support the one end of the long workpiece, and another mainly to hold the tools for like operations like drilling, rimming, and tapping. So sometimes some operation that can be done by using tools. That tools are drilling tools, rimming tools, or tapping tools. Okay. So generally we use this tailstock in these operations. Okay. So it has mainly two functions or two purposes. One is to support the one end for long workpiece, and another one is to hold some tools for the operations like drilling, rimming, tapping, or you can say sometimes we have another operation that can be performed using this tailstock. The next part, it is called as a carriage. Now the carriage provides the means for mountings and movings of different cutting tools. So that is called as a carriage. Now carriage, if you see, this is called as a carriage. So whole assembly is called as a carriage. So it consists of various mountings and moving of the cutting tools. So if you see, this is another diagram, that is layout of carriage. So there are number of parts that is used in this carriage assembly or carriage. So first part, it is called as a saddle. Okay. So this part is a saddle. So if you see this saddle part, it is the H type of casted or casting fitted, which is on the bed, that will move along the outer set of guideways of the bed. So this carriage assembly, it will move along these guideways. So that is called as a saddle part. And we have this saddle, which is called as a saddle part. So here, if you see, it is not shown in this saddle part. So it is a saddle part. Now next part is the cross slide. So this part, it is called as a cross slide. Okay. So here it is shown in this cross slide. It is shown by this part. It is called as a cross slide, this part. So cross slide, it is mounted on a transverse bar. Okay. So this is the transverse bar. Why it is called as a transverse? So axis is along this direction. So transverse direction. So it is called as a transverse bar on the saddle. And this cross slide, it can be moved by means of feed screw by using controlled hand movement. Okay, so by using this hand wheel, we can move this cross slide along this length. Cross slide is used to move the cutting tool along the direction of perpendicular to the axis of rotation. Now, axis of rotation is along this direction, and this cross slide, it carries tools, it will move along the perpendicular direction. So because of that, the cutting will be takes place. Okay, so that is the function of cross slide. Now we have a compound wrist part. So this part, it is called as a compound wrist. Here, this part is known as compound wrist. So it consists of a base which is mounted on cross slide. So this compound wrist, it is mounted on cross slide. And an upper casting, the base is gradually in angle of swivel of the compound wrist through any angle. So we can move this compound wrist at any angle. Okay. So at any angle, we can move this compound wrist. The upper casting, this part, upper casting is mounted on a guide wedge of the base, and it can be moved along the guide wedge by using the hand wheel. Okay. So this compound wrist is can also be moved. Next part, that is the tool post. Okay. So this part is called as a tool post. Above this compound wrist, it is called as a tool post. So it is mounted on a compound wrist, and cutting tool, it is clamped inside this tool post. So we clamp or fix the cutting tool in this tool post. Okay. So cutting tool or a single purpose, single point tool or multi-point tool, it can be fixed in that tool. So these are the tool post. And the last part, it is called as an apron. So this, the below part, it is called as the apron. Now, what is the means of apron? It is attached the front of the carriage. It contains a mechanism which gives the manual as well as automatic motion to the carriage. Okay, so by means of this apron, we can give the automatic or manual motion to the carriage as well as to the cross slides also. So for manual movement, the carriage along the bed, it can be moved by using this hand wheel in front of the apron. And in case of automatic, we have a gear arrangement is there. So by which we can have automatic movement of these cross slides and all that. So the hand wheel shaft has a pinion and its other end is connected to the rack of the attached to this. So we have this pinion. So this part is called as a pinion and this is the rack. So that is rack and pinion is arrangement is there. Rotary motion is converted into reciprocating motion by using this rack and pinion arrangement. So this is the whole assembly in the carriage. So it has saddle, cross slide, compound post, compound rest, tool post, and the apron. Now we have a feed mechanism, that is the power transmission mechanism. So the power is transmitted to the apron by using the feeding mechanism, and it is located to the left of the bed, that is called as feed mechanism. So power transmitted to apron by means of rotating feed rod through the gearing, and the clutch arrangement is also there. So if you see, this is called as the feed mechanism, or we can say this is the feed shaft, and again this lead screw shaft. So again power is transmitted from this headstock or from gearing to this whole arrangement, that is called as a feed mechanism. Now for cutting threads, generally this feed mechanism is used to have the external threads on the workpiece. We use this feed mechanism, that is feed rod and the we can say a screw, lead screw. So for cutting threads, the drive is given by using lead screw by the direct connection between apron and lead screw by using the split nut. Okay, so for only thread cutting operation, we use this feed rod, then screw leads and the split nuts. So this is the feed mechanism. Now we'll see some of the specification, how the technical specification of lathe will be there, or we can say what are the important specification will be there, so that we can have different types of lathe that can be used. So if you see, lathe can be specified by giving various data regarding maximum diameter of the workpiece, that is called as a swing diameter. Then the distance between centers, that is between two centers, live center and dead centers. Then the height of centers, then hole through the spindle, number of spindle speeds, that is called as what are the varying speed is there, and their speed range. Okay, that is from say 200 RPM to say 2000 RPM, that is called as a speed range. So at that speed range, we have a number of spindle speeds. So it is 220 RPM, 440 RPM, 800 RPM, 200 RPM, so on. So based on, we have a multi-speed gearbox which having a different spindle speed. Then we have feed range, then motor power rating, and net weight. So some of these specifications are very much important for specification in lathe. So this specification, it can be differs based on type of lathe. So sometimes for some different length, we have another important we can say specification will be there, but these are the main specification. So for example, some of the specification I have mentioned here. So we have a height of center, okay, that is 165 meter. Then swing diameter, that is diameter of the maximum diameter of the work that can be there, that is 355 mm. Then distance between two center, that is live center and between headstock center and tailstock center, it is 700 mm. Then hole through spindle, it is 35 mm. Then we have numbers of spindle speed steps. That is, we can say 16 speeds are available. Okay, so that is called as number of spindle speed. So if there is a speed range of, say, for example, 200 RPM to 2000 RPM. So in that speed range, we have 16 speeds are available. Okay, that is called as number of spindle speed. Next, we have motor power rating. So it is 0.75 kilowatt. Okay. And we have a net weight of that speed lathe, or we can say lathe. It is, for example, 475. So it are the some of the main specification, but other specification are also mentioned. So if you see one of the examples, so it is one of the lathe machine. It has a model of alpha number 0311, which is of 7 feet long. So if you see this lathe, it has various, we can say, specification, like bed length will be there. That is the 7 feet. That is the bed length. So length of the bed. So this length, it is called as 7 feet length. Then bed width is there. So this width of the bed, it is called as the width. Then center height. So from this center, this height. Okay. So this height, it is called as center height. Then spindle bore. So this spindle bore diameter, it is there. Then bed saddle, bed tailstock ram diameter. So this is called as a ram. So its diameter. Then we have surface width, compound width, tool post width, counter bracket. Then there are a chuck plate will be there. So based on different types of lathe, other specification that can be mentioned in that specification of lathe. But these specification are very much important. That is height, swing diameter, distance, hole through speed, then number of spindle speed, what is the power of motor, and we can say net width. Other than this, we have different types of specifications. Then we will see what are the application of this lathe, why we use the lathe, and why the lathe is the most important machine tool that is used in any production process or manufacturing process. So the lathe are designed for a variety of versions to suit different operations or different applications. So lathe is most versatile, conventional machine tool that is used for performing large number of operations that we'll see in next videos. What are the operations that can be performed? For example, we have turning, taper turning, then boring, drilling, reaming, thread cutting. Then we have a form, then a groove making. So there are number of operations. Again, the lathe are used for production of different components that are mentioned here. So plane and stepped shaft, bolts, small tools, dies, gauges, fixtures, instrumental parts, pipes, which is used in petroleum industries, wheels, crankshafts, screws. Okay, so these are the different parts that can be manufactured by using lathe. Then we have some special attachment. So because of that, the different parts that can be produced, that is called as polygonal turning, then slot milling and grinding. So that can be used. Then lathe can also be used for doing drilling and other drilling aligned operations, such like drilling, boring, countersinking, reaming, then threading. So these are the drillings and all other operations that can be using by using tailstock arrangement. Okay. Next one is, so these are the various applications that are used, and this is the main part of your machine tool, that is the lathe machine. Okay. But in modern, or I can say in we can say industry 4.0 or industry 3.0, we have computer operated lathe machine, that is called as numerical control lathe machine and computer numerical control lathe machines. Okay, so this is all about the machine tool that is called as lathe machines. So this is all about we can say today's video. So we'll stop this video. So thank you for joining this video, and also please try to subscribe my channel and like the video. Thank you very much.